these are the last two standards in this test that we're covering. We reviewed all of those wonderful properties, which I think, well, I know, shouldn't have looked completely brand new because we covered a lot of them in Algebra 1. And then we practiced some of the applications of that. So let's do part C here together. It'll be a similar problem to this one. I'll change it up just a little bit. And this will be a good reminder on how to deal with some of these properties. This is going to review all the properties.
Why don't you just break out the calculus signs?
Alright. Now let's talk through some of the things that I kind of gave as guidelines. What was the first thing I told you to look for in these types of problems? In order to start simplifying.
Parentheses.
Parentheses. So I see one pair of parentheses here. You look inside the parentheses, are there any like terms I can combine?
No.
No. So then you go directly outside the parentheses. Can someone tell me what to do with that? 2.
A square.
It is a square.
Distribute.
Distribute. And you gotta make sure you distribute to each
Oh crap.
term. Okay. So what is 4 squared if I distribute to the 4?
16.
Okay, so I can write that as a
Good job,
16. And then x to the negative 3 squared. Remember, that's a power on a power situation. So if you have a power on a power situation, you multiply. Good. So you should get x to the negative 6. And then y squared, right? Because we distribute to each term. Okay, I'm not going to do anything else at this point. So everything else I'm just going to leave as is because I'm going to do this piece by piece. Now, if you have a problem like this where you have actually two different fractions you're multiplying together, take care of your parentheses first, just like we have in the past. And then, this is usually the easiest way to approach it. We want to make one fraction. So I'm going to make one fraction by multiplying across the top and the bottom. So let's just look at the top. If you multiply across the top, it becomes like some of the problems we've already done. You just look at it like that. So we're going to multiply the whole numbers together first. So 16 times 2 would give you 32. So go ahead and write that down. And then we have x to the negative 6 times x cubed. Now when you're multiplying two things with the same base, what do we usually do with the exponents? You add them. So what is negative 6 plus 3? X to the negative 3. Okay, so again, you just write down x to the negative third. We're going to take care of the negative here in a minute. And then y squared times y.
Y to the third.
Y to the third, because that's like y to the first. So on the top, we're going to have 32 x to the negative third y cubed. Yep. And then we're going to do the same thing on the bottom there. So you're going to multiply across with the whole number. So 4 times 10 would give you 40. X to the negative 2 times x to the first. Yeah. Just x to the negative first, right? Because you add the exponents together. So negative 2 plus 1 gives me x to the negative 1. And then y cubed times y to the negative third. What is 3 plus negative 3, though? 0. And what's anything to the 0 power?
1.
So you could write y to the 0 if you want, but really, isn't that just going to make it disappear? Because 1 times anything is just itself. So you could write y to the 0, and I'm going to write that here in your notes just so that later on if you look at this, you don't think it just completely disappeared arbitrarily. But y to the 0 we know is just 1. And then this...
These are answered.
No. We have to flip some stuff around, but this looks similar to the stuff we were doing last week. So we just have one fraction now that we're dealing with. And last week, again, we split it up into parts. So we dealt with the numbers first, the whole numbers. 32 divided by 40, does that reduce? 4 over 5. 8 goes into 32 4 times, into 45 times. So we should have 4 over 5. And then we look at the x to the negative third and x to the negative first. Now, since both of them are negative, you could do a flipperoo,
But then you still subtract them.
but then you'd still have to combine them somehow. But it might make it a little bit easier to think through. If we were to flip them, wouldn't it put the x to the first on the top and the x to the third on the bottom? Stick with me here, guys.
I'm with you.
Okay. So if we flip it to make the exponents positive, that's telling me I have now 1x on the top and 3x's on the bottom. So how many are going to cancel?
One.
One's going to cancel, leaving me x squared where?
On the bottom.
On the bottom. So you could look at it that way and write x squared on the bottom. The other way you can look at it is we could take -1 and subtract a -3, and you would get x squared on the bottom that way too. Either way you look at it. And then y cubed over y to the 0. What is y to the 0 again?
1.
Just 1. So I don't have anything. I have to subtract from y cubed. That ends up being my final answer. Okay.
That was a fun part.
We are going to practice these properties, especially today and tomorrow, on whiteboards, but not quite yet. Flip the page. This next stuff, though, is stuff you've already been doing.
We get reviews this week, Megan.
Tomorrow, Wednesday, Thursday. Can we talk with you? Okay. Couple terms I just want to make sure. I mean, these shouldn't look foreign to you. There's some words in there that you should recognize. But let's start with polynomial. What does the term poly mean? Many. And the nomial means numbers or terms. So a polynomial function is just a function that has many terms. So that's a basic, that's just going to be where we leave it. I could get more technical, but that's really all we need at this point. So a polynomial function is like the overarching name for quartics, quintics, quadratics, cubics, linears, anything like that. Because all of those functions have more than one term, usually. We're going to look at maybe some of the more common ones down here. But the next chapter, or the next unit that we're going to be dealing with is getting into more cubics and quartics. We've been dealing with quadratics a lot, but they're kind of all the same family of functions. It's just you're adding on another term. Leading coefficient. Anybody know what the word coefficient means? Good. They do. Co means together. So it is the number that is together with the leading term. So coefficient, this is the number attached to the term with the highest exponent. So in a quadratic, your leading coefficient is the a value, because the a is always attached to the x squared term. In a cubic, it would be the number attached to the x cubed term. So it just depends on it's not always the first number, but if the highest exponent is the first value, then it is the first number. All right, degree. When we're talking about the degree of a function, degree is just referring to the value of the highest exponent in the problem. So with a quadratic, the degree would be 2, because that's the value of the highest exponent in the problem. And then standard form is just the polynomial is written in descending order. Now, that's not something that's brand new to us, because we're used to writing quadratics in descending order. We always want our x squared first, and then our x, and then our constant at the very end. So we're going to put in a chart here kind of the most common ones, and this is a list of ones that you already know about. Degree 0, degree 1, degree 2, degree 3, degree 4. These are the most common ones we deal with in Algebra 2. We don't really go beyond that normally. The type name for a 0 degree would be a constant. Because if you have anything raised to the, remember, the degree is the value of the highest exponent. So if you have x to the 0, What is x to the 0?
0. 1.
Anything raised to 0 power is 1. So then you would just have a number. So what that would look like as a function is just f of x equals 2. We could write 2 times x to the 0 if you want to, but we know that anything raised to 0 power is just 1. So that would be what the function might look like. And we call that a constant because that's like a horizontal line, doesn't change, so it's a constant value the whole way through. Degree 1 would be a linear function. These are ones that we spent the majority of our time, maybe the first month or so of class. So that type of function would look like, I don't know, 2x plus 1. Have the form like y equals mx plus b. What is the name of a degree 2? Quadratic, good. So if your highest exponent is a 2, those are the ones that we've been dealing with all chapter. Quadratics. And so standard form might look like x squared plus 2x plus 1. I could just have f of x equals x squared. That would still be a quadratic. You don't have to have all three terms there. For number 3, or degree 3, you would have a cubic function. That just means you have a 3 as your highest exponent. And you could have other terms. You could have x squared and x and all that. But as long as the highest exponent is a 3, that's a cubic function. And the last one is a quartic. So that's an example of what a quartic would look like. Now, for all of these, I want you to take notice that the x is raised to a power. A polynomial is not something that looks like this. Because where is x here? The x is the power here. This is actually called an exponential equation because the exponent is the x. Notice here that all the x's you have are being raised to a power, they aren't the power. They're being raised to a power. So polynomial follows that type of pattern. The reason I say that is because if we have a function that looks like that, and I ask you to identify it as a polynomial, the first thing that you have to tell me is it a polynomial or not? This one has 3x to the 4th, but what about the other x? It's under a square root. It's not being raised to a power here, right?
Yeah.
Not a whole number power. So we would say that this is not a polynomial. And you have to give me a reason because of the square root of x term. Even though you have 3x to the 4th, that square root of x makes it not a polynomial. Your polynomials are pretty straightforward. Every x that you have has to be raised to a whole number power. This one would actually be called, and we haven't gotten into them yet in this class, but if we had to name this function, this would be called a square root function because of that square root. So if I gave you the function 4x to the 4th minus 3x cubed plus 2, is that a polynomial? Because I had two x terms, right? One x is being raised to the 4th, the other x is being raised to the 3rd. So since both x's are being raised to a whole number power, we would say that yes, this is a polynomial. And then we're going to name it. Now, if we had to name this polynomial, you have to look back up at your chart, and let's say, well, let's first label it what degree it is. What's the degree of this function? You look at the highest exponent, and whatever that highest exponent is, the degree is the value of that. So this is a degree 4 polynomial. The type would then be a what? Quartic. Good. And then for reasons later on, it's going to be very important that we can identify the correct value of the leading coefficient. So as long as your polynomial is written in descending order, which this one is, the leading coefficient is the number attached to the term that has the highest exponent. So in this case, it'll be 4. Okay, just so that I know you guys can do this or not. I want you to do this next one on your own, and then we'll talk about it.
You go crazy when you do it wrong.
I just added another term.
Exactly.
Alright. So same thing, identify if it's a polynomial. And if it is, write the degree, the type,
Do you want us to
and the leading
in
coefficient.
that form?
You wouldn't have to. I was just going to make sure that you correctly identified it. Okay, so first question, is this a polynomial?
Yes.
Yes, it is. Because none of my x's are, nothing weird is happening to my x's. They're all x's being raised to a power of some sort. What degree is it?
3.
This one's actually a 3, because your highest exponent in the whole problem is a 3. So we would call this a degree 3, which would make it type called
Cubic.
cubic. And what is the leading coefficient then?